Good day, viewers. Here is another question that involves the use of Kirchoff's law in answering the question. In the circuit, we have the 2 ohm resistor and 4 1 ohm resistors. And the question is, we have to evaluate the net current passing through the 2 ohms resistor. So as usual, we will assign currents in the sections of the circuits and also try to adopt one loop for each closed circuit. Okay, so let's assign our currents. So let's assume that we have a current I1 here. Let me use different ink. We have I1, here we have I2, so let's call this I2. And let's say here we have I3 flowing off, and in this case we want to take I1 flowing here. So our essential junction is going to be here. This is our junction where current splits into 2. And we can see also our 2 important loops are, we can take this clockwise as loop 1. If we want, we can take this anti-clockwise as loop 2. Remember, it doesn't matter how we take our loop. Once we keep to our two conventions of writing the potential difference across the battery and across the resistors. Okay, so let's take this loop, take this point as P, so that we can be able to write our KCL. So at P, we write KCL, Kirchoff's current law. So we have to also adopt one thing. Current coming, in this case, I want to take current coming to be positive, current leaving negative. So my current leaving is I1. I1 is leaving, so it's negative. I2 is coming to P, so it's positive. And I3 is positive also because it's coming to the junction. So this is equals to 0. This is my equation number 1. Okay? Then let me take loop 1. Let me change the marker. For loop 1, starting with let me start with the 2 ohm resistor. My current I2 is opposing my direction, so my potential drop across 2 ohm resistor is minus 2I2. Minus 2I2. Then coming to my 4-volt battery, I'm reaching the positive terminal of the battery, so my battery is positive 4. Coming to my 1 ohm resistor in this side, my current I1 is the one passing through the 1 ohm and is opposing me because the direction of my I1 is down, that my direction is upward, so I'm going to have minus 1 times I1, so it is I1. Coming to my 2-volt battery, I'm reaching the negative point first before the negative terminal. So my battery is minus 2 volt. Then coming to the 1 ohm here is opposing me because my current is inside 1 ohm is coming this side while I'm moving this side. So my potential drop across this 1 ohm resistor is minus 1 times I1. So minus 1 times I1. So this is going to give me 0. This is equation number 2. So my third equation will come from my loop 2. Okay, coming to loop 2, my loop 2 is going anti-clockwise. So let's start with the battery. I'm following this path, so my battery is minus 4. I3 into 1 ohm resistor. The current and the loop are in the same direction, all of them upward, so it's going to be positive I3, 1 times I3. Then coming here, My I2 into 2 ohm is opposing me. I'm coming down, the current is going up, so there will be minus potential drop, negative potential drop across 2 ohm resistor, so it's minus 2 times I2. And my battery will be positive because I am coming down, so I'm going to meet the positive terminal first before the negative terminal, then plus my current here. The current through this region is I3, and it is in the direction of my flow, so it's my loop, so it's supposed to be plus positive I3 times 1. So this is 0. So let's see the simplification here. Minus 4 cancel 4. I3, I3, 2I3, so I have 2I3 equals to, this 2 will come to this side, so it's going to be positive 2I2. Or this implies that I2 is equals to I3. Okay, we have this information, I2 equals to I3, and let's come back to this region. I2 equals to I3. If we come back to this equation, it means I1 is equals to twice I2 or twice I3. Okay, so let's keep this information aside. This equation told us that I2 equals to I3. We use it here. So let's see equation 3. Minus 2I2, I minus I1 minus I1. So this will give us minus 2I2 minus 2I1 minus I1 minus I1 minus 2I1. 4 minus 2 is going to be plus 2, and this is equals to 0. So divided through by 2, we are going to have minus I2 minus I1 plus 1 equals to 0. So if we simplify this, this means that I2 I1 plus I2 equals to 1. We'll take this one to the side, so it's negative. Negative cancel, negative cancel, negative, so we have this equation. But I1 equals to 2I2 from this equation, so we insert this value here, and this will give us 3I2, 2 plus 1 equals to 1. So I2 is equals to 1 over 3 ampere. From this equation, I3 is also 1 over 3 ampere. And using this equation, therefore, I1 is equals to 2 over 3 ampere. So these are our currents. Our currents are here. I2 is 1 over 3 ampere. I1 is 2 over 3 ampere. And also I3 equals to I2 from here, so it's going to be 1 over 3 ampere. So these are the currents, and therefore the current through the 2 ohm resistor, which is I2, is 1 over 3 ampere. So this current is 1/3 of an ampere. Okay, that's all. So